Hi there. In previous videos, I have shown how to implement a simple text adventure game using BASIC and using Turbo C. So today we see how to implement the same game using Assembly 6502C for the Apple IIe computer. So I have another video series where we explore how to do 6502 assembly programming in detail, and you can watch this video as part of that series where we put in practice many of the theoretical things we have learned so far, but you can also watch it as on its own, where you get a feel of what it is to write a text adventure game using assembly. I will anyway put links to the videos where we explore some of these instructions and techniques in more detail, so you can go and you can get a deep dive view if you are interested. So, one disclaimer. I am not proficient in 6502 assembly, so I'm very familiar with the Apple IIe because it was my computer from teenage years. But back then, I did not know how to program assembly, and I felt like learning, and over the past few months I have been learning. So I'll show you the way I would do it with what I know today. And anyway, this series is not meant as a perfect implementation, perfectly optimized, professional implementation of this game in different languages. It's more about giving us a feel of these different languages and how we can accomplish the same thing in very different ways using different programming languages. And also to understand a bit of history of programming languages and the tooling that we use to program, and how we landed in the place that we are today when it comes to programming. So I hope you have fun watching this video, and let's go.
Okay, so the first step is just to print out the current location. And for now, we are just going to say you are in an empty room and offer the user a prompt, get some input from that prompt, and then print out, just echo what the user has printed. So it's not much of a game, but that's a start. So if this code looks completely unfamiliar to you, I recommend that you check my series on 6502 assembly, episodes 1 through 6, that are going to give you a basis of what this is about. And more specifically on episode 12, we go in more depth about routines, I/O routines, to get input from the keyboard and to print entire sentences in a generic way, which are the routines that we are using here. So our code listing, we put this starting at memory location hexadecimal 4000. Then we are just defining here a number of monitor hooks that we need to printing strings and getting input from the keyboard. The actual routines for printing and getting input, they are here on separate files. So we can keep our program manageable by splitting it in separate files. So you can see here that we have a print string. And this print string is, as I explained in more detail, described on episode 12 of our assembly series. And then there is another subroutine to input a string and also to print a string based on a certain memory address. And I will not get into the detail of how these things work, because you can already see these on the previous tutorial videos that we have. But I will show you the use that we have for these things. So here we're basically printing, you are in an empty room, and then printing a carriage return and ending the string. And then we print the prompt here. And here we ask for an input string and then print that buffer. So if we assemble this program and you execute it, you can type something here like, I don't know, take lamp, and we have the echo of that, and our program ends. So this is step 1. So the next step will be then to introduce real locations, and not only saying an empty room as a fixed string, and also start introducing simple commands. So for that, we'll need a few, to define a few memory addresses on page 0 that we will use for communication between our main program and some of the subroutines. And also we will need the keyboard buffer that's on address hexadecimal 200. And here I can already show you that we have some differences. First, we introduce now a command for quitting. So it's just called quit. So here we say, okay, we have the string quit. And then we take this string and we put the address of that string on pointer 1 that we just defined on page 0, pointer 1. Then we take the keyboard buffer, that's hexadecimal 200, and we put that address on pointer 2. And then I introduce the new subroutine that compares the two strings. So we put the pointer to one of the strings on pointer 1 and to the other string on pointer 2, and we compare them to. So if they are the same, the outcome will set the 0 flag. So our branch equals, so if it's equals 0, if the 0 flag is on, we exit. So if the string that's on the keyboard buffer is matching the string quit, then we exit the program. And we have a new file with the string comparison, and this is the string comparison. So I will not explain it in a lot of detail, but again, if you review our prior episodes on 6502 assembly, you can easily understand this code. So let me show you this in action. So we assemble the program, we execute it, and then if I write quit, we are out. Okay, so that's one thing we have accomplished here to introduce our first command. But we also, you can see that the description of the location, it's a bit more colorful now, and that's you don't see this in here. What you see here is that we just say you are in, and then we load the Y register with something called lock IDX. What is this? So this is just a location holding 1 byte, and that byte is basically the index of the location that we are currently in. So we start at location 0, and location 0 is the empty office. And these things, they are defined in a new file called location.s, and that file, we have this subroutine get location description. So you basically what you do is you put on pointer the index of the location, and then you call this subroutine, and then when you come back from this subroutine, pointer is going to point to the string that describes this location, and we just print the string, right? So the part that says here you are in is shown here, and then all the rest, an empty office, there is a door to the south and a locked door to the east. This is actually coming from the string pointed to by PTR. And if we take a look at this location file, so we start by just defining a bunch of strings, which are the 4 locations we have in our game. And then we have this get location description routine that takes the index of the location that's on pointer. Then we put this in a different pointer 2 that we use. And I try here to have some documentation that explains what is the input, what's the output of the subroutines, and what are the registers or pointers that it destroys or messes up during its execution. But so we put the contents of pointer into pointer 2, and then we start at location 0, right? This is our base address. This is where the locations start. We start at location 0, and we use here the register X as a counter for how many strings or how many locations we have counted. And then we start a loop. And in this loop, what we do is we first check whether pointer 2, which is the pointer that we keep updating, is equal to the location that we want, right? So if it's equal, the index that we provided at the beginning, and if it is, we are done. And when we get to done, we just put this content, put the address of that string on a pointer and return. If we are not done, we keep looping, and here we add 1 to the address. So we start here, and then we go one by one, checking whether this is matching carriage return. So we keep checking when I'm sorry, not carriage return, but 0, 0, the new line or string termination character. So we keep incrementing our pointer until we find this, and when we find this, we increment to the next location. So we have one counter that we use for the strings. So every time we find this 0, 0, we increment that counter, and we have another counter that's for characters that we keep increasing until we find this guy here. And then when we go to the next string, we make it 0 again, which is what happens here. So you see what we are doing is character by character, we are moving forward and keeping account of how many locations we have. And when you hit the location that you want, you basically return the pointer to where you are, which will be the first character here. So, and by the way, if you want to understand more about how we are adding, which happens here, how we add one, this is explained in detail in episode 9 of our assembly series. I hope this explanation is enough that you have a basic understanding of how this works. So now let's, you see, we are on location 0, which is the empty office. And we don't have yet a command go that allows us to change location, but what I can do is change the location manually here in our source code, and then assemble it, and then execute. And now we should have a different description. Yes. So now we have both a first command, the command quit, and we also have the ability to display different locations, different strings for different locations depending on the location that we are in, which is basically the contents of position log IDX. So that's the second step in our game. And step 3 is about introducing the go command, at least two directions to get started. And we have extended this code a little bit. I have commented out the echo of the command. And now you can see that we, after checking for the quit command, we go to a new section called evaluate commands, where we're checking whether the command is go north or go south. And here we have strings determined for commands go north and go south. And we have a new file command go. And what we do here again is that string comparison. We check whether we have typed go south. And if we did, we jump here. And what go south does is it takes the current location address, and we change the location to, I'm sorry, so let me explain this better. So I have introduced a new subroutine in location.s called new location index. So what happens is you put on pointer 1 the place where you are, and then you put the direction. So if you are in that location and you go in that direction, where should you land? So if you go to location.s here, so what we do is we are going through an array called exits. So we have exits for each room. So for room 0, and room 0 is the empty office, if you go north, you actually this is the origin, so the origin is 0, 0. So if you are on 0, 0 and you go north, you land on location FF. And FF basically stands for there is no possible exit. So there's no exit in that direction. However, if I go on location S, then I land on direction south, then I land on location 0, 1. And we can actually see that by looking at some documentation that I added here to GitHub. So you see here's the indices of all the locations, and FF means basically nowhere, so you cannot go there. And the directions here, and FF is, yeah, there's no exit on this direction. And this is the map of our game. So you can see we are here on location 0. So if you try to go north, yeah, there's not really anything on that direction, so you cannot go north. But if you go south, you land on the stock room, and the stock room is location 0, 1. So I hope that helps making sense of what's going on here. So if we are on 0, 0 and we go north, we land nowhere. And if we go south, we land on 0, 1. And we don't have any other possible direction. From 0, 0, we can only go south, at least now, because as you know, we have this door locked for now. So it's not possible. Later it becomes possible. So similar to the way that we have iterated through these strings until we find the right address, we do the same here with these exits. So we keep iterating the same way, incrementing in 5 by 5 bytes. And why 5 bytes? Because each one of these records is 5 bytes long. So we keep iterating until we land exactly on the address that we want. In this case, if we say, okay, we are in location 0, and I want to go south, this will be the destination. And that's what we do here. We say, okay, we are currently on this location, which we know it's 0, 0 because that's where we start. And we want to go in direction 2, that's south. Then we call this, and then in the address pointed to by PTR, and this is what this parenthesis means. So it's this basically taking the address that is pointed to by this pointer. We compare with FF, because if it's an invalid direction, then we say, oh, you cannot go this direction. And then we just return, right? We don't do anything else. But if the direction is not invalid, then what you do is you update location index to become the new destination. And in this case, it's going to be room 1, the stock room. And this is for going south, right? And then for going north, you have a similar thing, with the difference that here, instead of using the direction south, you're using the direction north, but pretty much everything else is the same. So let's take a look at how this works. So you are in a dark room, and then you go, oh, I'm sorry. The reason why it says this, I forgot to update the initial location, right? We should start at 0, 0. So let me just start it again. Okay, so I go south. And then I go north. And we see that now we have these commands to go south and north. But there's something that's not looking nice here, right? And that thing is we are basically duplicating all this code. The only thing that really changes here is the direction, depending on whether you type north or south, and all the rest is the same. So our next step is to turn this into something that's more generic to go in any direction, and that's what we're gonna do. So in order to accomplish this, we changed a little bit our strings here to separate the go part of the command from the direction, the 4 directions. And then our command go implementation looks familiar up to this point. So we are checking against the command go part, but here we are calling a different subroutine. Before we were just comparing strings, always the full string. So if we had the entire command like go north, we would compare the entire thing. And now we want to compare the left part that contains the go command and the right part that contains the direction. So I have introduced a couple more comparison routines. So now we have compare left. And compare left is easy enough. We basically keep comparing character by character up to the length that we want to compare, which is passed in a pointer PTR here. And compare right, it's a bit more involved because it requires that we find the length of the string. And here I have introduced a new command, string length, that basically tells you that. So we go to the end of the string, and then we keep coming back until we reach the length that we want. We compare up to from the end to the beginning, and we have to compare from the end to the beginning on the 2 strings, right? Because they may be of different lengths, so we need to keep the length of both strings, and then work our way from the end towards the end characters that we want to compare. So I will not explain this in detail. I leave it as an exercise for the reader to interpret this. If you can follow the story of how we do loops, and all of this is explained in the first 6 episodes of our assembly series, then you can figure out this code. But trust me, what we do here is we provide 2 strings, and then we provide a length, and we ask to compare them from the right up to that length. So this is what happens here. We compare if the command is go, we come here to check the direction. And then on the direction, we basically check the right part to see if it matches north or south and so on. And once we do this for the 4 directions, and once we know the direction, we just go based on the current location, and based on that direction, we take a new location and we go there. So this is what we have introduced on this step, and let me show you that this is working. I have to type it properly. And you see now we are not interpreting the whole command, but the 2 parts of them. So before we can do something and go east or west, we need to find a way to unlock this door, and that's our next step. Okay, in order to unlock the door, we of course add a new command, unlock door, and we also go to our command misc new file. So I suspect I might add some other simple commands here, so I just called it command miscellaneous. But for now we only have unlock door, and we begin pretty much like the other commands. We compare if the user has typed unlock door, and if the user has done it, we come here. But now there's quite a lot to unpack here about how we're implementing this. So when you unlock the door in this game, you are actually changing a bit the game world. What I mean by that is we start in the empty office, and the description of the empty office is that you have a locked door to the direction east. And you basically cannot go east. If you try it, you cannot go in that direction because the door is locked. So when you unlock the door, we are changing the description of the empty office to say now you have an exit east. And we are also changing our matrix or our arrays with destinations. So if you are in the empty office room and you go direction east, now instead of being impassable, you actually go to the dark room. So what we do here, and we also need to test for a few conditions, right? So first, we need to check that you are in the empty office to unlock the door. I mean, if you're in the stock room, there's nothing to unlock or anywhere else, only from the empty office. So we check if the location is 0. If it's not, then we show an error message saying, yeah, there's nothing to unlock here. And then we need to change the description of the location, right, of the office location. So we call the subroutine that gives us a pointer to that location description. And then I introduce here a string copy. So the string copy is now available as part of the, if I'm not mistaken, the print string. I should probably consolidate all these different print string, input string, compare string into a single strings.s file. But yeah, that's I leave this as an exercise. Just for organization, it will not change the behavior of the program. So the string copy, it's quite straightforward. We're basically iterating from all the characters in the origin and then putting them at the destination. And so coming back here, we copy this string over the one that was previously there, right? Which we got from this pointer. One important thing we need to make sure is that the string that we are copying here is actually shorter than the existing string, because otherwise if it is longer, what's going to happen is that we are going to invade the other string. We're gonna overflow into the next string, and then we will basically erase the 00 terminator. We're gonna end up with fewer strings, and the way our get location description works, it's going to fail. But there's also another problem, because imagine that we overwrite this with the shortest string. Let's say it ends around here, and now here we put like there is a 00 at this point. What will happen is that we have a 00 here, a 00 here, a 00 there. So if we are asked, let's say, for location 1, right? So our algorithm is going to consider this location 0. We'll find here a string terminator, and we'll consider that this is string of location 1. And that's not what we want. So I made a small change here. And now instead of using 00, I mean, we still have the 00 as the string terminator, but I'm using the carriage return character to be the limiter between the strings. And I have changed accordingly the code that iterates to find the description. You can see changed accordingly here. We could have used something else. It just needs to be a character that we do not intend to make as part of our string. And for now, the carriage return is not part of our string, so that's fine. So that being said, let me go back there to the unlock. So here we are basically overriding the existing description with a new description that says that we're not talking about locked doors anymore, because there's no locked doors anymore. And we are also doing a similar thing here to change the exit, right? So you might recall that in the location file, we have this matrix here that indicates what are all the exits from each room. So if we are on room 0, 0, and we take an exit east, now we don't want it to be FF anymore, because FF means no exit. We actually want this to be pointing at the dark room. And the dark room in our example is location 2. So we call the new location index subroutine to give us a pointer to the location in memory that has the exit in direction east from the empty office. So we say, okay, for the empty office and for direction east, give me the pointer. And what we do now is we first check if this pointer is already pointing to 0, 2, because if it is, means we have already unlocked the door, and then we show the appropriate error message. Otherwise, what we do is we put the number 2 in that memory location, and that becomes the new exit. And then we say you have unlocked the door. So this is how it works. Let me show you. You see that now the description, we are still in the same room, but the description has changed. And then we go east and we are in the dark room, which is what we wanted. So notice that for now we are not yet checking whether you have the key, right? Because we don't have objects, we don't have the key yet, but we're gonna have it in the future. There's also something else I would like to mention. So when you have your Apple II computer and you are running no disk operating system like DOS or ProDOS, the keyboard input routines will just, when you type something on the keyboard, they are going to put the characters on the keyboard buffer and show them on the screen. That's all. However, when you load a disk operating system like we are doing, this particular system is using ProDOS. ProDOS is going to add some extra hooks to memory. So every time you type something, it tries to validate it as a ProDOS command. And it so happens that we have a ProDOS command called unlock. And the way that we are now circumventing this is by calling these two hooks, set vid and set keyboard. Basically, they remove these extra ProDOS hooks while we run our program. And then when we exit, we actually restore these hooks by calling the ProDOS business, the basic interface, PRD BI, which is this hook here. So that's why I can type unlock door and it will interpret as my command. So let me show you what would happen if we were not doing this. So what I'll do here, instead of start making this initialization, I'll just skip right through the command loop. And I will also not do this cleanup on our way out. I'll comment out this line. Let me show you what happens. Okay, so now if I just say unlock door, it's poorly written, but the result is going to be the same. So we have this path not found, and we got exited out of our program. So what the hell is going on here? So what happened is that we have the ProDOS hooks in memory. So it's trying to interpret this as a ProDOS command, and the command unlock, you have to pass a file as a parameter. And we just pass some random string that it's not the file name, and then we get this path not found, and because it's an error, we get back to the prompt. So we do not want that. So that's why we added this thing here. that we remove these hooks. So before I run the program, now with the hooks, I want to show you something. So for instance, catalog is a valid ProDOS command, and it's basically listing. It's like listing the directory. So these are the files that exist. So you can see we call the catalog command, and it's all good. And now we run our program, and we say unlock door. And because we have removed the ProDOS hooks from memory, now this will work as we want. But then if I go out, the catalog command doesn't work anymore because we removed the hooks, right? But we did not put them back. So that's why it's important to put them back here. So I'll assemble this and execute it. And now we behave as we want, and when we go out, everything works back again. So that's also something that I realized while writing the handling of the unlock door command that needed to be sorted out. So now we arrive to the final step. So we have the game complete. I will go a bit faster now because I believe you understand by now all the basics. I have also done some housekeeping here to make our code more organized. So first thing you see here, I don't have those constants anymore. They are actually now in a file called common. So everybody depends on these memory addresses and on these monitor hooks. So now this is in a common file. And you see that I have moved these put instructions from the end of the file here to the beginning. So basically what this put is telling us is to take all the content from that file and just move it here. So it's like a macro. It's like in the end, when the assembler is trying to assemble this code, it's just taking all the code from all these files in this order and just assembling it all together. So the end result is still the same, but when we read this code, it's now much more organized. So we still have some data that is part of the basic file, but we have moved this to common. And also you see all the commands, the strings that I had for each one of the commands, they are now part of the command themselves. So we really have everything that has to do with command take is part of the command take.s and so on. Then we have all these things in here. Then we do what we already knew, right? We have this initialization of removing the ProDOS hooks. Then we print a banner. And then we start the command loop as we know it already. And here we have something new that's about objects. So I have introduced the whole thing about the key and the lamp and all objects. And let me walk you through this because this is quite important. So now we have this objects source file. And here we do something similar to the location. We have the object descriptions and we have the current location of the objects. And we have subroutines to get the object location and to get the object description, which is the string. And those are very, very similar to the ones we use for location. And we also have another one that basically lists all the objects, like you see a lamp, you see a key, if they are in the current location. So if you understood the prior explanations about the other subroutines, this one will make sense for you. So I'll leave it up to you if you want to read these in detail, but this is basically what they do. And also I declared some constant here for the total number of objects that we have. Right now we have 2, the lamp and the key. and also defined a new location that's like a virtual location. That means that something it's in the player's inventory, and that if that's hexadecimal AA. So if it's location AA, then it means it's in the player's inventory. If it's in location 01, 0, 00, 01, 02, or 03, then it's in one of the rooms. I decided to end with that command misc file and really separate the commands for unlocking the door and also a new command for lighting the lamp in separate files. But before we go there, let me show you the commands that have to do with the inventory. So we have a command take, and take first matches the left part of the string to see if it's take, and if it is then we check the right part of the string to see if whether it's the lamp or it's the key. And once we have returned the object, we do something very similar to what we did with the location. We get the object location. Let's say it's currently on room 00. We check if we are in room 00, right? Because you cannot take an object that's not here. And then you show, yeah, an error message. But if we are in the location and the object is there, what we do is now we make the object to be in the inventory. This is this constant is AA, right? So now the location of the object is now a location AA. And the command drop is the opposite operation, but if it is currently on location AA, it's in the inventory, then we just update to the current location. So we are dropping it in the current location. And if it's not in the inventory, we say, yeah, you cannot drop what you don't have. Then we have an inventory command. And the inventory command is again, we first check for the inventory, if we are matching the inventory command. And then we basically iterate through all the objects, and you say, okay, you are carrying this and that, so on. Finally, we have a command to light the lamp, and this command is another command that changes the world state, because when you are in the dark room with the lamp unlit, then it's just a dark room. But if the lamp is lit, then you have a different description, and you can see the door that takes you outside, the door south. And also the description of the lamp changes. Now it's, instead of just saying a lamp, we say a lit lamp. So this is what we do here. We change the object description to a lit lamp. And we change the location description to say now, instead of a dark room, we are in an empty room with doors leaning west and south. And we change when you go south from the dark room, now you go to the outside. And also we change the description of the lamp. Excuse me. Of course, you need to have a lamp to do all these things. And finally, we have a help command, and the help command only shows you what are the commands that exist, like go, take, drop, inventory, etc. In case the player is lost. So now we go for a final demo of the entire game. When executed, we see the banner. We start in an empty office and we see a lamp. By the way, I don't think I mentioned this, but here in the main routine, we are now calling this display objects subroutine that shows what's in here. So we can take this lamp, and now we can check our inventory. Of course, you need to type it correctly. And then it says, okay, you are carrying a lamp. So you go south, and we see here a key. Now I take a key. and my inventory now shows that I have them both. I go back north, and if I try to go east, I cannot go, the door is locked, but now I can unlock the door. And by the way, this is something that we added here. Now to unlock the door, you need to have the key. So let me find the code that we check that. We are doing it here. We are checking if the key is in the player's inventory. We did have the key, right? So now we can go east. And we are in the dark room. If I try to go south, I can't. I mean, it's all dark. So what I do now is light the lamp. And now I see what's going on. I'm in an empty room. By the way, let me drop the key to show you the drop command. You see, I just dropped it here. It's not in my inventory anymore, just a lamp. And also the lamp, it's the lit lamp now. Also, if I was with a problem, I could ask for help. But now I can go south. And when I go south, I am in the world outside and I have won the game. And this is actually implemented here. Now I am checking for a game won condition. So if I am, as part of my main loop, if I figure that my current location is the same as outside, that means the game has been won. And then we say you are in the world outside, and then you say we have won the game. And that's our implementation of the get lamp game in assembly 6502C for the Apple IIe. I hope you have enjoyed this video as much as I enjoyed making it. This was super fun. As I told you, I'm not a proficient assembly developer. I use this as a way to get a hold of 6502 assembly, because that was like a childhood dream to me, and now I feel it's completely fulfilled. Also, I feel that's a good wrap up to a number of episodes we had in the Assembly 6502 series, putting in practice many of the things that we learned there. And if you haven't watched those videos, but you are now interested after watching this one, I recommend that you check out my assembly series. I will continue working on different implementations of this GetLamp game in several programming languages of historical interest, so we can learn together about how programming languages evolved, about how it made easier and easier to program until we are in the point that we are right now. And if you have made this far, I would ask you to subscribe to my channel. I would really appreciate that. And this way you're gonna be informed immediately when we have more videos, when we have more fun stuff here. So thanks for watching, and see you next time.